Today I am going to explain how to minimize a DFA. What is the need of minimization of a DFA? A minimized DFA containing minimum number of states need less time to manipulate the language in computer. That's why we minimize DFA. You see one example how to minimize a DFA. Suppose this is the given DFA containing 6 states, that is Q0, Q1, Q2, Q3, Q4, Q5. Among them 3 are non-final states and 3 are final states. So set of states Q0, Q1, Q2, Q3, Q4, Q5. If you want to minimize a DFA, first you have to draw the transition table. This is the transition table. For 0 input, these are the next state, and for 1 input, these are the next state. Since it contains a number of states, the total number of states 5, so I have written set of states. So what is the first procedure? What is the first step? First, you have to divide the set of states into 2 subsets. The first subset contains the non-final states. So non-final states means Q0, Q1, Q2. So first subset, that is Q0, Q1, Q2, and the set of final states Q3, Q4, Q5. So first you have to divide set of states into 2 subsets. The first subset contains non-final states and the second subset contains the final states, and mark it 0 equivalence. Now it is 0 equivalence. Next we have to find 1 equivalence. To find 1 equivalence, what will you do? Just you see whether Q0, Q1, Q2 are 1 equivalent or not. Q3, Q4, Q5 1 equivalent or not. How to find out equivalent? First you have to take two state. One is Q0, another is Q1. So Q0, Q1. For 0 input, what will be the next state? Q0, Q1. You see Q0, Q1. For 0 input, the machine will go to Q1, Q2. That means this is Q1, this is Q2. So Q1, Q2, you check whether these states are available in the same state or not. Q1, Q2, these are available in the same states. So Q0, Q1, this is 1 equivalent. But we have to consider for 1 input. Then Q0, 1, then Q1 for input 1, what will happen? This is Q0, Q1 for 1 input. The machine will go to Q2, Q3. So here Q2, Q3. So if you consider Q2, Q3, Q2 present here, Q3 present here, since these are not available in the same states, so it is not Q0, Q1 is not Q0, Q1 are not 1 equivalent. If for 0 input, the next state will be available in the same state, and for 1 input, the next states will be available for the same set, then it is 1 equivalent. Since it is true, but it is not true, that's why Q0 and Q1 are not 1 equivalent. That's why we have to write Q0 and Q1 separately. Now we consider Q2, Q0, Q2 or Q1, Q2, which states are 1 equivalent. So we consider Q0, then Q2. Q0, Q2 or Q1, Q2, which are 1 equivalent. Because I have separated Q0 and Q1. So Q0, Q2 for 0 input, what will happen? Q0, Q2 for 0 input, the next states will be Q1, Q2. This is Q1, Q2, and these are in the same states. So this is these are in one equivalent. That means Q0 and Q2 are one equivalent. Again, you see for one Q0 1, Q2 1, what will happen? Q0 for one input, Q0 for one input, it will go to Q2. Q2 for one input, it will go to Q4. That is Q2 and Q4. So Q2 and Q4, Q2 present here, Q4 present here. Since for one input the next states will not be available in the same state, so same set, so we have to consider Q0, Q2 are not equivalent. That's why we consider Q1 and Q2. Again, Q1, Q2. For 0 input, what will happen? For Q1, Q2, for 0 input, the next states are Q2, Q2. So Q2, both are in the same state, Q2. Similarly, for one input, Q1 on one input, Q1 on one input, it will go to Q3. Q2 on one input, it will go to Q4. So Q3 and Q4, Q3 and Q4, these are available in the same state. That's why Q1, Q2 are one equivalent. But Q0 is not one equivalent. That's why I have written in a single state. So this is one subset, this is another subset. Similarly, you see Q3, Q4, Q5, whether these are one equivalent or not. So for this purpose, we consider Q3 and Q4. So Q3, Q4. So what will happen for 0 input? Q3, Q4, Q3, Q4 for 0 input, it will go to the next state Q3, Q4. So Q3, Q4. These are in the same state. So these are one equivalent. Again, Q3 for one input and Q4 for one input. This is Q3, Q4 for one input. It will go to Q5. This is Q5. This is Q5. Since these are in the same states, so Q3 and Q4, these are one equivalent. Then we consider Q3, Q4, Q5 means either Q3, Q5 one equivalent or Q4, Q5 one equivalent. Then Q3, Q4, Q5 already one equivalent. That's why I have to check for Q3 and Q5. Q3, this is Q5. So Q3 for 0 input, what will happen? Q3 for 0 input and Q5 for 0 input. Q3 for 0 input, it will go to Q3. Q5 for 0 input, it will go to Q5. So this is Q3, Q5, Q3 and Q5. These are available in the same state. So this is one equivalent. Again, Q3 for input 1, Q5 for one input. Q3 for one input, it will go to Q5. Q5 for one input, it will go to Q5. So Q5, Q5. That means for 0 input, the next states are available in the same state. For one input, the next states are available in the same set. That's why Q3 and Q5, these are one equivalent. That means Q3, Q4, Q5, these are one equivalent. So after finding one equivalence, you check for two equivalents. If you check for two equivalents, since Q0 is a single state, so it is not required to check. This is Q0. Again, Q1, Q2. Q1, Q2 for 0 input. Q1, Q2 for 0 input, it will go to Q2. This is available in the same set. Then Q1, Q2 for one input, it will go to Q3, Q4. Q3, Q4, these are available in the same states. That's why Q1, Q2 are two equivalent. Q1, Q2 are two equivalent. Again, you check Q3, Q4, Q5. So first you check Q3 and Q4. Q3, Q4. The next states will be for 0 input Q3, Q4. These are available in the same set. Then Q3, Q4 for one input. Q5, Q5. These are available in the same set. So Q3, Q4. These are two equivalent. Q3, Q4. Then you check either Q3, Q5 two equivalent or Q4, Q5 two equivalent. So you have to check with Q3 and Q5. Q3, Q5 for 0 input, it will go to Q3 and Q5. Q3 and Q5, these are available in the same set. That's why it is one equivalent. Again, you check for one Q3, Q5 for one input, it will go to Q5. Q5. That means Q5 is in the same set. So Q3, Q4, Q5, these are in the Q3, Q4, Q5, these are two equivalent. Now you see one equivalence and two equivalence. One equivalence is same as two equivalence. So you have to see if the two consecutive equivalence partitions are same, then you have to stop your process. Now we stop the process because this equivalence, one equivalence equal to two equivalence, we stop the process. After stopping the process, you consider Q0 is one state, Q1, Q2 another state, and Q3, Q4, Q5 another state. By using this state, you have to draw the state transition diagram. So what will be the state transition diagram for minimized DFA? Since each subset we have taken as a state, so Q0 is a state Q0. Since Q0 is the beginning state of the DFA, given DFA, so it is beginning state. Then Q1, Q2 another state, Q1, Q2 another state. Then Q1, Q3, Q4, Q5, this is another state. And since Q3, Q4, Q5 final state, so for minimized DFA, this is also final state. Now you see the transition. Q0, for 0 input, it will go to Q1. So this is here Q1, then this is 0 input. For 1 input, it will go to Q2. That means for 1 input means we write like this. Then Q1 for 0 input, it will go to Q2. So like this, here is Q2. Q1 for 1 input, it will go to Q3. So here 1. Then Q2 for 0 input, it will go to Q2. Finished. Q2 for 0 input, it will go to Q4. Q2 for 1 input, it will go to Q4. It is over. Q3 for 0 input, it will go to Q3. That means this one. Q3 for 1 input, it will go to Q5. That means here is Q5. Q4 0 input, Q4. Q4 0 input, Q5. This is over. Q5 0 input, Q5. Q5 1 input, Q5. So this is the minimized DFA, which contains only 3 states. So your given DFA contains 6 states. After minimizing, we will get a minimized DFA containing containing 3 states. And here you see the transition for 0 and Q0 is the state, and 2 transition for 0 and 1 over Q1, Q2. This is another state. For 0 input this transition, 1 input this transition, and for 0 and 1 input, 0 and 1 input, this is the transition for this state. So this is the minimized DFA. Thank you.